Thank you for viewing this RFID Community Connect video from AIM. AIM is an industry association for automatic identification technologies. It's not only RFID, but barcoding, IoT, or any other technologies that automatically identify and capture data. If you want to learn more about AIM, go to aimglobal.org or reach out to us to set up a one-on-one call where we can tell you a little bit more about how AIM can benefit your business.
So for our next session, we have Randall Grein from Hana RFID. He will be presenting on RFID and tires along with Peter Ramirez from Michelin.
So, hello everybody. Peter and I are the co-chairs of the Rain Alliance Tires Work Group. I heard Chris Brown in the last presentation mention that the Rain Alliance does training. We are actually here hosting the Tires Masterclass, showcasing how RFID is currently being used in the tire industry and giving some best practices and answering questions from the participants on how they can utilize RFID in their tires or at whichever reading point that they're experiencing the tires with RFID.
Excellent. I'm Peter Ramirez. I'm with Michelin North America. For us, that's US and Canada is our kind of a market territory, and that's important because I work in standards and regulations and am involved in a number of the smart or connected tire disciplines, which one of them includes RAIN. And so I spend a lot of time within RAIN and within RFID and working with AIM.
So in our presentation, we're going to talk about how RFID is transforming tire traceability, maintenance, and circularity. I like to call this the why presentation, why RFID in tires. So if we look at how tires have been identified historically, one of the main identifiers is the DOT number. The DOT number is traditionally set up by production lot, meaning if you're running 100 tires, 1,000 tires, or 10,000 tires, all of those tires are going to have the exact same DOT number, and that's Department of Transportation. So it's also used as a standard within the United States. Tires are required to have a DOT number. However, because of the way that it's applied, it doesn't identify the tire as an individual asset. We saw some issue with this in the late 90s, early 2000s. There was a pretty infamous recall that 14.4 million tires were subjected to. Because those tires didn't have an individual identifier, the tire manufacturer had the responsibility of recalling all of those tires and then replacing them, which, as you can imagine, was a huge financial burden. So if we look at some of the ways RFID has an advantage in where it's being used, RFID, because in its nature, it's a unique identifier, you're able to look at that tire as an individual asset. The first place RFID was used is in the racing industry. A lot of tire companies have gone from simply selling racing tires to the various teams to a leasing model in which they provide a specified number of tires to teams on a given race weekend. This is done to ensure that there's a better competition between the participants. Previously, teams with higher budgets could just buy more tires, and then, of course, that could give them a competitive advantage. The leasing model makes it more even footing, fair play for all the teams that are involved. On a given race weekend, depending on the racing category, up to, I've been told up to 7,000 tires could be brought by the tire manufacturer on a given race weekend. That's a huge amount of tires to be managing and inventorying over the course of the race weekend. It also has the additional benefit of monitoring tire choices. Previously, some form of visual fiducial would be on the side of the tire to indicate whether it was a slick tire, whether it was used for the rain, whether it was a harder or softer compound. By using RFID, you can manually capture what tire is being used, and that can then be used in the broadcast of the sport to ensure the fans a better experience. They can more closely monitor the team's strategic choices, and that can actually be showed either on the screen if you're watching from home or put up onto a larger screen if you're there watching in person. The next categories that we saw RFID being rolled out into were commercial vehicles. So we say TBR, that's truck and bus radial. The radial tire is the most commonplace design used today. Actually, you should know about that. That's a Michelin invention. But truck and bus radials, because they are very large and very expensive, the tread actually decays faster than the tire body does. What that means is you can then add a new tread when the previous one has expired and use that same casing, the body of the tire, multiple times. How many times you can do this depends on the tire type. It also depends on regulations of the country in which the tire is being used. But ensuring that you have a unique identifier on that casing, you can then have more accurate monitoring of how many times it's being retreaded. Commercial tires also change hands quite a bit because if you bring a tire to a retreader, it's not guaranteed that you get that tire back 100% of the time. So when you have a tire changing hands throughout its entire life cycle, being able to identify and track that asset begins to become paramount to ensure that you're following regulatory requirements. Additionally, when you look at tire fleet managers, if you think of a truck with 18 tires and you think of a fleet management service who's operating millions, if not tens of millions of trucks, that begins to become an astronomical amount of tires to be tracking manually with pen and paper. So automating the data capture on where those tires are, how many times they've been retreaded, how much life is remaining in those tires, that data becomes extremely critical for running an efficient operation. The next place we're seeing is PCR, which is passenger car radial. That's what a typical consumer would have on their vehicle. That's also what you would be buying in the replacement market. In order to maximize distribution, being able to identify individual assets becomes important. So when a tire manufacturer manufactures a tire, they will then send it to a distribution center. The distribution center then sells it to the tire reseller who, we know the big ones here in the US are in charge of actually getting that tire to the consumer, whether it's a box store or whether it's an online service. So again, those tires are changing hands a number of times, and managing inventory becomes critical for running an efficient operation. The other big driver is the OEMs, the actual vehicle manufacturers who are putting tires onto the vehicle when they're being constructed. Ensuring that you have the proper tire fitted on the proper wheel going onto the proper vehicle becomes critical to make sure that you don't have any type of mismatches. So why is RFID the identifier of choice that we're seeing growing extremely fast in the tire industry today? Because the RFID tag that's being used in the tire industry is designed and optimized to be embedded inside of a tire, it becomes a permanent fixture inside of the tire itself. It's not a sticker, it's not an exterior label, it's not a serial or a DOT number that's embossed into the side of the tire, which could get scuffed off if you hit a curb. It's actually structural to the tire itself, and it cannot be removed without detrimentally damaging the tire. So the RFID is embedded from the moment the tire is built, and it remains there at the end of life when the tire is entering recyclability. Because it's permanent, it can't be changed or modified. RFID has the ability to be locked, and at which point the actual identification code inside of it cannot be altered anymore. So some of the benefits, we are seeing legislation globally discussing having difficult to recycle items have a unique identifier. One that's being discussed quite heavily today is the digital product passport in the EU. That's requiring difficult to recycle items have a unique and, most importantly, permanently affixed identifier on difficult to recycle assets on an individual level. And that should make the asset easy to identify, whether it's going through customs, whether it's at recyclability, or whether it's by the individual consumers or businesses who are utilizing the product. Some other use cases that we're seeing is the smart manufacturing. We touched on this when we mentioned automotive manufacturers verifying the correct tire and wheel assembly. Also, counterfeiting. Believe it or not, in the tire industry, there are big issues with counterfeiting. When you buy a specific tire from a specific brand, you expect to get that level of performance. If the tire is carrying a brand or a model name but was not truly produced by that maker, that quality can be less than what you expect, and there can be safety implications in that as well if you're using a tire in an environment that it's not rated for. Additionally, anti-theft, there are issues where people rent, whether it's a rental vehicle, a U-Haul, take the tires that could be brand new on a rental vehicle and swap them out with some used ones, return the vehicle. You just got a free set of tires for the cost of the vehicle for the day. So car rental agencies and other large fleet management companies are looking at RFID to identify and verify that the tires that left with the vehicle are the tires that are ultimately returned with it. In additionally, after sales support, when you have large fleets who are using huge amounts of tires, they're trying to manage inventories, they're trying to manage retreads. Being able to speak with the company who produced those tires has additional benefits, and it's a good use case for the tire manufacturers themselves. So we think that illustrates a clear why. Looking at the cradle to grave traceability requirements that are upcoming in the EU, and we are also being told are upcoming in China as well. Being able to optimize the manufacturing of not only the tire itself, but the vehicles that are receiving it. Looking at the tire ecosystem, having better identification ability, whether it's at the distributors, the resellers, fleet managers, retreaders, all of these different touch points throughout the tire process benefit from RFID. And ultimately, looking to reduce waste. Recyclability and recycling is only truly viable when you can understand the compositional materials of the item that you're trying to recycle. So being able to identify what a tire is made out of, what you can then reclaim from it, and being able to get that information through global data standards organizations such as the GDSO makes tire recycling a much more viable process.
Yeah, and I wanted to spend a little bit of time talking about the Rain Alliance Tire Work Group. Tag technology is not new. It's been around for a long time. Tire technology is not new. It's been innovating for more than 100 years. And this conversation about tires, RFID, rain tags, and how they work together, many of you were involved in the early 2000s. In fact, AIM, through its RFID experts group, published a document, and many others brought those together to sort of try to figure out how we're going to work on making this a success together. And since the Rain Alliance has had a tire work group, since it's been around 2020, we exist to sort of support the educational and informational materials that draw on all of those external references, ISO, GS1, many of the different regional associations which publish the need to know about their markets, and the tire work group serves really to exist to bring that together to serve that broad industry adoption. How do we sort of elevate this to make this something that we can all do? The tires masterclass is a good example. Chris mentioned the encoding class, which is very successful. We have been inside of the Rain Alliance doing a tires masterclass now 7 or 8 times. This is the first time we've brought it to the US, and it's taking place simultaneously today, tomorrow, and we have a GDSO workshop on Thursday. I think I counted about 60 people, just under 60 people. We have about 8 tire manufacturers who are attending, representatives of 4 to 5 tag manufacturers, lots of people who are in the value chain of both RFID and rain, as well as tires. And so the goal of that is really to bring it together. And inside the tire work group, we meet, we have deliverables, we have projects that we're working on, and we'll be present at the Madrid event coming up in just a few months in Spain. And so if you're interested in this, please reach out to me or to Randall. We meet the first Wednesday of each month. You can see the times in the bottom right, and we look forward to serving you. And we'll leave some time for some questions.
Great. Thank you guys for this presentation. It was fantastic. I've had this question now a couple times, so I'm going to merge them into one. At what stage of tire manufacturing is RFID typically embedded?
So you mean like what is the adoption rate of tire manufacturers who are using embedded tags?
I think it's when in the process.
Oh,
RFID introduced.
Okay,
Yeah,
what stage?
that's
Okay,
how
so
I interpret it.
I understand.
Yeah.
No, thank you, Randall. Okay, so it is, in order to have it embedded, it's done at the manufacturing of the tire, and then it's cured inside of the tire. That the embedded is one of the ways of attachment classification that's defined by ISO. It can be a label, which would be removed at the point of sale. So that's another thing that can be done at the tire's inception. And then another is we can add a patch. And so you might imagine that if there's a tire that has been in use for several years and the stakeholder, the trading partner wishes to adopt, they could use a patch and they could attach that to the inlay. But the really important thing is the embedded tag is the only attachment method that will last from cradle to grave.
And then can it be potentially used for mobility infrastructure improvement?
It can. The tag does one thing really well. It says this is who I am, but it in concert with other data that's collected by the vehicle, data that's collected by maybe smart infrastructure and smart intersections, then can be brought together to sort of help to answer that question. So RFID and brain tags do one thing really well. It says this is who I am, but and that offers a super strength to be able to accomplish the identification, but it has to be used with other data and other data sources, and that's really the important part of having a session like we're having this week and sort of bringing stakeholders together, vehicle manufacturers, people who are retreaders, even people who are fleet operators. They control and manage data that's generated from other sources. And when you bring that together, then you can tell a story. A real simple example is that a tire by itself, as Randall mentioned, that's involved in a recall, a defect notification. It doesn't know that the vehicle doesn't know when the tire has been removed from that vehicle. But a TIN, a tire identification number, in association with a VIN, a vehicle identification number, which is also unique, those together then do tell a story. So if the TIN is on the VIN, and if the TIN is removed from the VIN, think how powerful a story that can be to really helping to make sure that a tire that needs to be recalled can be, and associated to all the other data that's associated with that vehicle. So I think that's just a short explanation.
And then I'll ask, this is the last question. I know we have a couple others, and again, we will answer those as part of the post-event materials, so be on the lookout for that. Does embedding the tag into the tire reduce the ability to read the tag at a distance?
I'll turn that over to you if I may.
It's an interesting question. So obviously, yes and no. A tag that's designed to be embedded inside of the tire is a different design than a tag that's designed to be used in free space. When we look at RAIN RFID tags, whether they're in an inlay form factor, whether they're an embeddable tire tag like we're discussing today, the material on which the tag is going to be used, whether it's cardboard, whether it's denim for something that's going to be sold in the store, that's going to have an impact on the tag's design. So when we are looking at actually taking a tag that's intended to be embedded inside of a tire, the design considerations are such to maximize the tag's performance. So what you would see in practicality is one of the tags that goes into a tire, if you were to read it as a standalone unit, it would perform extremely poorly. But inside of the tire, you are then able to get a much longer read range from it. So RAIN RFID is somewhat dependent on material, and that's ultimately, at the end of the day, governed by physics. But this tag that we're discussing today is specifically designed to perform optimally when it's inside of a tire.
And in the room, they're teaching the physics portion of it. And one of the slides that they're going to get to that a lot of people don't think about is that the performance, the readability of a tag can and often does improve as the tire wears. So a tire that's put on a drum, which is basically is a lab environment that rotates and spins, that the read performance can improve actually over time. And that's just one of those things that you wouldn't think is intuitive, but it's one of the unique features about what happens when you merge a tire and tag technology together.
Great. And then I'll just end with this. Ernesto put in a note from AIDC 100 about a remembrance to the late Dr. Pat King, who was a key figure for Michelin, who led the early development and global standardization of RFID tags for tires. So did want to add that as well.
Yeah.
So
yeah, thank you. That's there have been a number of people who have stepped away from this, and we've sadly lost a few of the pioneers. So thank you for that reference.
All right, and thank you, Randall. Thank you, Peter, for your time today. Looking forward to see what you guys are doing in the tire space here in the future as well.
Thank you
for having us.